In this lesson I will be talking about surjective functions, or as they are also called, onto functions. I'll start with an example, and the example I've picked for this is a cubic function as shown here. And we will look at the many ways we can represent this function first. For example, you can put in some values of x and get some values of y, plot them in a table, and then we can plot the corresponding graph. Of course, we can also show the same information in a mapping diagram from domain to codomain. Each value of x has a corresponding value of y over here. Or again, we can just write it simply as an equation. In this case, y equals x cubed plus 3x squared minus x minus 3. So now that we're familiar again with all the ways of showing this function, let's look at how we test a function for surjective. And here's the simplest way of looking at the test. If there is at least one arrow arriving at each point in the codomain, well, then it's a surjective function. So just like we have shown here, you can see each point in the codomain has at least one arrow arriving. Another way of saying the same thing is that the codomain and the range are now equal. Each element in the codomain is used up. We can say it more casually as, it often helps to think of it as like this, as the domain is like a question, the codomain is like an answer. So surjective is kind of thinking backwards. It's every answer has at least one question. So each answer in the codomain has at least one corresponding question if you work backwards. Yet another way of saying the same thing, if you're given a graph of the function, a horizontal line through the graph cuts at least once everywhere. So at least one arrow arriving at each point in the codomain, horizontal line through the graph cuts at least once. And yet again, another way of testing for surjective, if you're given the equation or the function in algebra form, for example this function here, if you write it as y equals 3x minus 7, well, again referring back to what I said earlier, the surjective, we can think of it as every answer has a corresponding question. So if we think of x as the question and y as the answer, here's the answer here, y equals 3x minus 7. If we rearrange that formula to get x, we have x equals y minus 7 over 3 now. So again, y is the answer. Y, let's put in any value for y here, for example 3 or 4, any real number at all. And it should be obvious that you will still get a real number for x. So any real number you put in for the answer or for the codomain gives you a real number for the domain. For every value of y, there is a value of x, is what we're really saying here. And that in itself is a test for surjective. Here's an example where that test doesn't work. Again, the function is x mapped onto x squared. If we represent it as an equation, y equals x squared, and rearrange to get x instead of y. So x squared is y, get the square root of both sides. Just watch out for square root here, it's plus or minus the root of y. Now again, surjective means every answer has a corresponding question. Every value of y has a corresponding value of x. But if you put in a value like minus 1 for y, minus 1 is allowed because y is a real number, as we can see here. Minus 1 is allowed for y, but the trouble is if you put in minus 1, you get x is root of minus 1, which is a complex number, which is not allowed for x because x has to be a real number. So we have just got a value of y for which there is no corresponding value of x. We have got an answer for which there is no corresponding question. Therefore, that function is not surjective. Sometimes a function starts off not being surjective, but we can make it surjective by adjusting the codomain. And here's an example. The graph of sine x is this wave graph here. If you look at the horizontal line test, it fails up here, for example, at the top and at the bottom of the graph, because it doesn't cut at all. It's supposed to cut at least once for surjective. However, we can make it surjective if we restrict the codomain as follows. If you leave the domain as it is, but if you change the codomain to only values between -1 and 1, because sine only ever goes down to -1, it only ever goes up as far as 1. So by restricting the codomain to -1 and 1, we're effectively cutting off any values above the crests of the curve here and below the troughs. And if we now do our horizontal line test again, we see now this time it does work, because we're any place you go between those two boundaries, it will cut at least once. Therefore the function is now surjective.